Hi, everyone. We're going to do one more thing with the data that we've collected in the chaotic oscillator experiment, which is we're going to look at Poincare sections of the data. Here, I'm going to go to a program that will help us graph these, and then we can describe it a little bit. There we are. So it's going to help if I read in some data. So I'm going to read in some of the data right now. There we are. This is the small amplitude motion. Very good. So first, in the red points with the lines between them, this is the original data that we took. The white points are a Poincare section at a phase angle of 350 degrees at the moment. That means these are the points that are acquired when through each cycle of the experiment when the phase angle of the motor was 350 degrees. Remember, the motor is continuously turning at a constant speed. It's continually rotating. And every period of motion of the motor, it goes through 360 degrees. So here I've selected out the points that were acquired at a particular phase angle. And what's important about that is just this. For periodic motion, once you know the phase angle, you know where the points should be located in the phase plot. So for example, here, as I sweep through different values of phase angle, I can see that I'm just selecting out points at different points in the phase plot. What's interesting is that this little group of points, that it stays together as we go around the cycle. That is, the motion is periodic and it's predictable, and it doesn't matter too much what the exact initial conditions are, which point we start at in a particular cycle, because this group of points stays together. Okay, now let's go and look at another piece of data. This is taken at larger amplitude, and it's a little more clear, I think, even though it's slightly nonlinear. Oops, that's the wrong one, sorry. Might take me a second to find it, I'm sorry. Should have figured it out which one it was beforehand. How about 9? Ah, there we are. Okay, let me rescale this here. There we are. And you can see that this is higher amplitude motion. The curve is a little bit, the orbit is a little bit asymmetric. In any event, as we sweep, here also the motion is periodic. So as we sweep around the phase and look at Poincare sections at different drive phases, the group of points that we've selected just orbits together. Once again, the motion is periodic and it's predictable. Okay, well now let's go look at the chaotic motion. And here it's very useful to look at the data that we took for the 2-hour acquisition, okay? That's this one here. And, very good. Let me rescale the x-axis. I think that looks good. And you can see it looks very different. Points taken at a particular phase angle are distributed all over the phase plot. Okay, now as we start advancing the phase and looking at different Poincare sections, you can see that everything looks completely different than it did for the periodic motion. Instead of seeing something that's orbiting around in a circle, we see a cloud of points that move. It's as if we were stirring a can of paint or perhaps kneading some dough. Now let's do that again. But now I want you to select a group of points and try to follow them as we advance the phase around in a circle. It's hard to do. But what you'll see is that the cloud of points does not stay together the way the point groups did for the periodic systems. Instead, as we go through the phase plots, they stretch out and finally become mixed in with all the other points in the plot. What that's telling us is that this system is kind of sensitive to initial conditions. It's not predictable. Here, let me stop. That is, it's not enough to just know the general area where a point sits in the phase diagram in order to know its future trajectory, because the future location is very, very sensitive to initial conditions. And even 2 points that start out very close together will eventually diverge as time advances. And that's what makes the motion unpredictable. Okay, well, what I wanted to show you here is that Poincare sections can be used to help us understand the physics of a chaotic system and see how it's unpredictable. Well, that's basically all I'd like to talk about now. So let me stop and stop this too. Thank you.